So in section 3.4, we are going to take a look at graphing linear equations. That gets what we're doing all week, graphing linear equations. Today we're going to look at how do we graph linear equations in standard form. Tomorrow we're going to look at slope-intercept form. So if you're familiar with like y equals mx plus b, how many people remember that? Y equals mx plus b. Or you've heard of it before? Yeah, it's going to be tomorrow. Okay, today is going to be a little bit different. Just a different way to write the equation of a line. So on your guided notes, where it says the, and then there's a blank, the blank of a linear equation, you're going to fill in the standard form of a linear equation. Is. And then you're going to write that down. AX plus or minus, could be either one, BY equals C. And the idea when they give you an equation in standard form, the A, the B, and the C are all going to be numbers. They could be positives, they could be negatives, fractions, decimals. In the two warm-up problems, let's just go back for a second. Example 4 and example 5, those are both examples of equations in standard form. In example 5, the number in front of x is a 2, the number in front of y is a 3, and the number on the other side of the equal sign is a 26. The 2, the 3, and the 26 are the A, the B, and the C. Bless you. In example 4, we have a 3, a 7, and a 14. That's the A, the B, and the C. So when you write an equation in standard form, they'll give you 3 numbers to fill in for the A, the B, and the C. It is important that the A and the B are not both the number 0. One of them could be a 0, but not both.
That's gonna make both 0.
What's that?
That's gonna make both 0.
If they were both 0, well, if they were both 0, then you'd have something like this. You would have, let's say A is 0, and then you had B was 0. So I changed A and B to both be 0.
So the answer would be 0.
So yeah, what's 0 times x?
0.
That's 0. And 0 times y?
0.
That's 0.
0, 0, 0.
So what happens is your x and your y both disappear. If your x and your y disappear, that's not the kind of equations we're going to be graphing today. The equation has to have one of those letters in it at a minimum. They can't both disappear. In fact, if they both disappear, you wouldn't even be drawing a line. You gotta have at least one letter in the problem to have it be a line. All right, so most cases where we draw a line, it's usually going to be something like that, or like that, or like that. It's going to be a line that's on a diagonal. Okay? But there are 2 special cases, and the 2 special cases are when we have a horizontal line or a vertical line. Okay, those are special. And I'm going to show you how you can quickly tell whether it's a special case. So we're under special cases where there's a number 1. You want to write down that if you have an equation where it's y equals a number, okay, like this. Do I write one right down here? Yeah. Y equals 3. That is a special case. Okay, the way you can tell that it's a special case is one of the letters is missing. Okay. What are the 2 letters that are supposed to be in the problem? Like, I just go back to what we did here. Look at example 4 and example 5. What are the two letters that came up in those problems?
X and Y.
X and Y. If you have X and Y, then it's going to be a line that's just on a diagonal. If you are missing one of the letters, it's going to be a special case. If the X is the letter that's missing, and all you have left is the Y, that is going to be a horizontal line. Okay, Y equals 3. No X. Okay, so when it ends up as Y equals a number, that's your horizontal. Well, in that case, the X disappeared. What's the other letter that could disappear besides the X? The Y. So let's say the Y disappears, and you end up with X equals a number, and the Y goes away. Does anyone have a guess what kind of line that would be? It's going to be a special case. It's not going to be on a diagonal. What's the other special line you could have? Yeah?
Vertical line.
Yeah, that's going to be vertical. Very good. And I'm going to write that down on the next. I'm going to scroll down. So that's going to be special case number 2. If you have an equation of the form X equals a number. And so under number 2, right to the right, you want to put down, if we have an equation that's X equals a number, that's a vertical line. Okay, and where do you put the vertical line? Well, you put the vertical line at the number. So let's say it was X equals 5. Okay, because the Y is gone, it's a vertical line. And it says the number on the other side is a 5. So it's a vertical line. 1, 2, 3, 4, 5. It's a vertical line at the number 5. So sometimes special cases are harder. I think in this case, the special cases are easier. To graph a special case, all you have to do is put either a horizontal or a vertical line at the number that it says to. Now you can't mix them up. Okay? If it's supposed to be horizontal, then it has to go left to right. If it's supposed to be vertical, it has to go up to down. Right, so on your guided notes, you have 2 blank grids right below the 1 and the 2. That was just to copy down these 2 examples. Okay, so that's X equals 5. That one goes on the right grid. And Y equals 3. That was on the left one. Yep.
Do we have to do exactly the example?
No, you could do a different one. I just put that as an example. But as long as you understand that X equals is vertical, that's what's important.
Okay.
Yep.
Can I see that?
Yeah, just a second. Okay. Did everybody get the number 2 special equation copied down?
What was the first one for the graph?
I think I did Y equals 3. I could have used any example. I could have done Y equals 2, Y equals 10, Y equals -4. As long as you understand Y equals is horizontal. All right. So let's try a couple graphs. Okay, so here's the first one. Actually, I think you guys have these both printed, right? Y equals 4 and X equals -2.
Mm-hmm.
You have both? All right, so why don't you try both of those? Okay, so first, figure out what kind of line it's supposed to be, whether it's horizontal or vertical, and then draw the line at that number. Okay. And you can do it right on your, right at the bottom of your guided notes. Okay, and we'll walk around and just make sure everybody's doing okay. All right, so let's take a look at these. So remember, to be a regular case, it has to have an x and a y in it. So let's look at the first one. Y equals 4. Is that a regular case or a special case?
Special case.
Right. What makes it special?
Because it doesn't have an X.
Doesn't have an x. Okay, it's missing one of the letters. So now, because it's a special case, we're either going to draw it left to right or up and down.
Left to right.
Yes, y equals always goes left to right. And we're going to draw a line left to right. How high up? At what number? At 4. Yep. So we're going to draw a horizontal line at 4. And it should go all the way across the graph. Just 1, 2, 3, 4, right there. And that's it. That's the first one. So the way you could do that on Edge Elastic, does anyone remember how many points do you need to draw a line on Edge Elastic? Yeah?
2.
You need 2. So you could click anywhere over there, and you could click anywhere over there, and it'll draw a line right through your 2 points on Edge Elastic. It doesn't matter where you click, as long as you click 2 dots anywhere that I just put them. It'll draw a horizontal line. Okay, let's look at 1B. Okay, is this a regular case or special case?
Special.
Yep, what makes this one a special case? It's missing the Y. Yep, it only has 1 letter. So that means it's either going to be horizontal or vertical. What kind of line is x equals? Yep.
Up and down.
Up and down, which is what do we call that kind of line?
Not special.
Well, no, it is special when it goes up and down, but what we call that a vertical. Yep. So vertical line. So we're going to draw a vertical line, and what number are we going to draw it at?
-2.
-2. So where's -2?
The other side. There's 1, 2, 3.
So how do I put it at -2? Like, do I go down 2?
You're going from
Up and down.
Up and down, right? At -2. So we go left 2. Put it right there. That's where your line should be. And on Edge Elastic, it'll do it a different color from the axis, so that way you can tell the difference between your axis and your line. All right. Any question on that? So the special cases, those are the easiest ones. There really is no arithmetic, any math we have to do for those. Actually, I just asked you guys that question already. When you're drawing a line, how many points do you need? 2. Right, you need 2. Okay, so, and that's exactly the same in Edge Elastic. If you want to draw a line, you've got to click in 2 spots, and then it'll connect your dots. Okay, so we need 2 points. Okay, I don't think this part's on your guided notes.
Is it example 3 or 2?
We're going to be getting to example 2A next. That's the next one. Okay, so we only need 2 points to draw a line. Think about, I kind of showed you guys this earlier. The way we're going to draw lines is we're going to figure out where does your line cross the y-axis and where does your line cross the x-axis. And then we're going to draw a line through the 2 dots. Okay, when it's not a special case, we're going to have to find these 2 dots, okay, using some arithmetic. And that's what I'm going to show you how to do. How will you know if it's a regular case and not a special case?
Because there's going to be 2 letters.
There's going to be 2 letters.
Or 2 dots.
Yep. So when you're doing a regular case, you're going to see an x and a y in the problem, and then we'll go from there. Okay, so I told you guys that there were 2 special points that we're going to find. This one and this one. What's the name of the axis that I just drew in red?
X-axis.
That's the x.
The one will be Y.
And yep, the vertical, that's the y. Does anybody know what you call that point right there? It's the point where your line crosses the y-axis.
Intercept.
The y-intercept. Yep. That's one thing that we need to find. We're going to learn how to find the y-intercept. And then this is a point where it crosses the x-axis.
Slope.
So what do you call, you want to know what you call this point?
Slope.
No, the slope is how steep it is. We're actually not going to work with slope today at all. We are tomorrow. Yep. This is called the x-intercept. So the way that we're going to graph lines is we're going to find that x-intercept and we're going to find the y-intercept. And now let's put that down on your guided notes. So where it says recall, blank is where the graph crosses the x-axis. You're going to fill in, actually I think you need to fill in both. X-intercept is where it crosses the x-axis. So likewise, the y-intercept is where do you think the other blank is? It's where it crosses the y-axis. Yep. So that goes right at the top of page 2. Now, what number, when we did the warm-up, I had you guys practice plugging in a number. What number did I have you practice plugging in? What is it?
0.
0. I had you practice plugging in a 0. Right, and there's a reason why we did that. Because when you plug in a 0, you are finding one of these two things. Which one you're finding? Well, depends on where you put the 0. Are you plugging the 0 in for the x, or are you going to plug it in for the y? We need to do both. All right, so let's look at this. Okay. I'm going to make a point on my x-axis. Right there. Does everyone agree that that point is on the x-axis?
Yes.
Okay. What's the coordinates of this point? Yeah.
Would it be 0 and 2 or 1? No. Would it be 0, 2, or 2, 0?
2, 0. Yeah. So the coordinate of that is 2, 0. How about that one?
4, 0.
That's 4, 0. And what about this one?
Negative 3, 0.
Negative 3, 0. Those are all x-intercepts. What do you notice about all of them?
They both have 0 for the y.
They all have 0 for the y.
Because they're not normally where the y array is.
Right, they haven't gone up and down at all. So all the y values are 0. 0, 0, 0. That's how you find an x-intercept. You have to make the y value 0. So let's write that down. To find an x-intercept, you plug in 0 for the y value. So it's just like we did in the warm-up. But now you know what that's called. When you plug in 0 for y, you're finding the x-intercept. Because x-intercepts always have a y value of 0. That's what I tried to just show you right there. Now, what's the other intercept we have to find besides the x-intercept?
Y.
Right, you got to find the y-intercept. Okay, let's think a little bit about y-intercepts. That's a y-intercept because it's on the y-axis. What's the coordinate of that point?
0, 1.
Yep, 0, 1. How about that one up there?
0, 4.
So that's 0, 4. And let's just pick one down here. How about that one?
0, -3.
0, -3. Yep. Those are all y-intercepts because they're on the y-axis. What do you notice about all the y-intercepts?
All the x's are 0.
All of the x's are 0. That's how you find a y-intercept. You have to let x be 0. Because that's what a y-intercept is. It's the x value has to be a 0. Okay, so you just have to remember which one is which. Plug in 0 for y, and you're finding the x-intercept. Plug in 0 for x, and you're finding the y-intercept. And then, once you have the 2 points where the line crosses the axis, we can draw a line right through the dots. And that's it. So it's not as simple as the special case. Right? The special case, you just got the horizontal or vertical. You don't really need to do any arithmetic at all. With these, you're going to have to do algebra, okay, to get the variable by itself and solve. Okay. So any question on that? All right, so now I'm going to give you guys something like we did in the warm-up. I'm going to give you an equation. I'm going to have you graph that equation by finding the intercepts. So first you'll plug in 0 for x, then you'll plug in 0 for y. Do you guys have the example written down for 2a? No? Okay. Let me put that up. Okay. So here is example 2a. What's that? Okay, yep, so just hang tight, give everyone a chance to do it. So what I want you to do off to the side is I want you to also write down what the intercepts are. And directions say label the point. So in this case, they just want you to write the coordinate of the x-intercept and the y-intercept. So parentheses and then a comma to write the whole coordinate.
So we're doing this.
So yeah, you're going to start, yeah, that looks pretty good. So, and then once you get your 2 intercepts, you're going to have your 2 dots. Draw the line through the dots. Right, so we'll give people a couple minutes to try that one, and then we'll take a look at it. Let's take a look at this one. First of all, is this a special case?
No,
No, why not?
it's both letters.
Right, it has both letters, so we're not going to be able to just quickly draw a horizontal or a vertical line. This one's going to be on a slant. So the way we have to do it is first find the intercepts. Okay. Let's start with the x-intercept. To find the x-intercept, what number are we going to plug in? What is it?
0?
Yep, we're going to plug in 0. And now where do we plug it in? What letter?
Right with 3, maybe? No. Yeah, 4.
What letter?
X. Y.
No, plug it in for y.
Yeah.
So to find the x-intercept, you're going to plug in 0 for y. So then we're going to have 3x plus 4 times 0 equals 12. What do we get, Molly, when we do 4 times 0?
Will be 3x equals 12.
Yep, so this is gone. So we just get 3x equals 12.
Beautiful.
And now divide each side by 3. We get x equals 4. And what's that again? That's my
Y. No X's.
That's my x-intercept. So that's where it crosses the x-axis. 1, 2, 3, 4. And what's the coordinate? And that's what I need to go plot on the other line.
Y. Wait, can you repeat the question?
So what's my coordinate for my x-intercept?
Oh, 4 and 0.
4, 0. Yep. Okay, so there's the x. What's the other intercept that I need?
3, 83.
What do we call it though?
Logic.
The y-intercept. Okay, so what number are we going to plug in to find the y-intercept? We're going to plug in 0. But where are you going to plug it in? What letter?
X.
X. So now we're going to plug in 0 for x. Okay, so go back to your original problem. It's going to be 3 times 0 plus 4y equals 12.
That'd be 4y equals 4.
Yep, 3 times 0, that you're always going to get one letter that cancels out, just like that.
And then we get y.
And what do you get?
Y3.
Y,
3. Y equals 3.
y equals 3. Perfect. How do I graph that on the y-axis?
0, 3.
Yeah, 0, 3. 1, 2, 3. So you go up to 3, put down the coordinate, 0, 3. One coordinate should always have a 0 in the first spot. One should have a 0 in the second spot. That's always how the intercepts work. Okay, so I labeled the points corresponding to the intercepts. I did that on the side. What's the last thing I have to do?
Graph it.
I have to graph it. So take your line and draw your line 3 points. And that's how you graph a line and slope intercept. Okay. Any questions on that? All right, let's try one more of those. Let's try this one. So same directions. First thing, is it a special case? No, why not?
Both letters are mixed, but y would equal -1.
So both letters are there. So it's going to be a line that's on some kind of diagonal. So do the same thing you did in the last problem.
Y would equal 1. Since it's not there. There's no number for y.
Right, you could pretend like there's a -1 in front of the y if you want. Yep. You could always, I probably won't write that on like a test, but you could always write it in if you want. Okay, so find your x-intercept, find your y-intercept, and then draw your line. All right, let's take a look at example 2b. So you have to find each intercept. Doesn't matter which one you start with. Okay, so which one do you want to do first? The y-intercept. Okay, so we're going to find the y-intercept. And to do that, what number are we going to plug in?
-1.
Not for an intercept.
X.
Number. What
Oh,
number?
0.
We're going to plug in 0. And where do we plug it in to find the y-intercept?
X.
Plug it in for x. So copy down your equation again, filling in 0 for x. 2 times 0 minus y equals 4. Okay, what's 2 times 0? 0. So that's gone. What am I left with after I do that?
-1y and 4.
-1y equals 4. And again, you can put that 1 in front. If it helps, you can do that. Can someone else tell me how am I going to get rid of that -1 in front of the y? Yeah? Yep, exactly. I'm going to divide by -1. -1 divided by -1 cancels out. And what's 4 divided by -1? -4. There's your y-intercept. So how would I graph that on here? Where do I put the dot for -4?
The bottom line, like
You look
the
down
bottom.
4.
Yeah.
Down 4.
Yeah.
Yep. 1, 2, 3, 4. And if you want to write that as a coordinate, what would that be?
0,
0,
-4.
0, and -4.
Yeah. Okay, so 0, -4. Okay, so there's your y-intercept. Now we're going to do it again for the x-intercept. Okay, so to find the x-intercept, what number are you going to plug in? 0. It's always 0. Always plugging in 0 every time. Now, where are you going to plug in 0? For the y. So set the y equal to 0. So we have 2x minus 1 times, we're filling in 0 for y. What's negative 1 times 0?
0.
So that's 0. What do I have now once I write down with that canceled out?
2x and 4
So 2x
equals 4.
equals 4. And to get x by itself, what do we do on both sides?
Divide by 2.
Divide by 2.
You get x equals 2.
And we get x equals 2. That's my x-intercept. Okay, how do I graph the dot for the x-intercept? Yeah.
Over 2.
Which way is over?
To your left, to your right.
To the right. Yep. So we're going to go to the right 2, and let's put a coordinate. So what's the coordinate for that dot that I just did? Yep.
2 and 0.
2, 0. Perfect. So we get the x-intercept, we get the y-intercept. What's the last thing I need to do? Yeah.
Where's the 2 lines?
Yeah, just go right through them. Just draw your line, about like that. I'll just fix it. And there you go. Question on it? All right, let's try. Let's try. We got 2 left, and they're kind of like that. Okay, so do you guys already have that written down? You're planning a banquet for your school? Yep. Yeah. Just make sure the numbers are the same. 180 people, 6 people large. A small table is 6, large table is 10. Perfect. Okay, so what we're doing in this problem is we are basically trying to make seating for 180 people. And there are, what's that?
That's a lot.
It's a lot of people. And there's 2 different size tables that we can have. We can have large tables and small tables. At a small table, you can fit 6 people. At a large table, you could fit 10 people. You don't have to come up with the equation. I'm giving that to you. So this equation represents what's happening in this problem. I picked the letters X and Y. I guess you could have done like S for small table and L for large table, but I think it's easier to use X and Y because that's what we've been using, so we'll keep using the same letters. So X is the number of small tables that you're going to rent, or whatever you need to do buy, and Y is the number of large tables that you're going to use. And you can pick any combination of large tables and small tables as long as you have seating for exactly 180 people. That's what they want you to have. So you could do all small tables, no large tables. You could do all large tables and no small tables. Or you could do a mixture, maybe like 10 large tables and 20 small tables or something like that. All right, so the first thing it says to graph the equation and label the intercepts. So really, this is the same as the last problem. This part, we're just going to do that together. All right, so let's graph the equation and find the intercepts. And once we graph it, then they want us to write down 4 possible solutions to the problem. A solution would be you tell me how many large tables and how many small tables I need to fit 180 people. And there's lots of different answers. Okay, they want 4. All right, let's start with part A. Can someone remind me what was the equation that they gave us that we're going to be graphing? Yeah, what was the equation they gave us?
6x plus 10y equals 180.
6x plus 10y equals 180. Okay, perfect. Okay, let's start with the x-intercept. What number am I going to plug in to find my x-intercept?
Y equals 0.
Plug in 0. Yep. And I'm going to fill it in for the y. So how about, Marie, can you tell me what my equation will look like when I plug in 0 for y?
6x plus 10 times 0 equals 80.
Perfect. And Eli, 10 times 0?
0.
That's 0. All right. So Madeline, what am I left with?
6x equals 80.
6x equals 180. And my last step to get x by itself. Yeah.
Divided by 6.
Perfect. Divide by 6. Divide by 6.
Which will equal 30.
Yes. 180 divided by 6 gives me 30. Okay. That's my x-intercept. All right. What's the other intercept I need?
10x.
Well, what's the name of the other intercept?
Y-intercept.
Y-intercept. Yep. So to find the y-intercept, what number are you going to fill in?
0.
0. And where are we going to fill that in?
X.
For x. Okay. So let's fill it in. 6 times 0 plus 10y equals 180. What's 6 times 0?
0.
So 0. And I'm left with 10y equals 180. And how would you get y by itself there?
Divide on both sides by 10.
Yep. Divide both sides by 10.
18.
And 180 divided by 10 is 18. Okay. Now, those are bigger numbers. So when I graph it this time, which I didn't put a grid on your paper, so for this one, you'll just have to draw your own grid. I'm not going to go by ones, okay, because that's going to be, it's going to be a little hard for me to graph that. I think I might go by twos. Okay, I think going by twos is going to be a little easier. All right, so let me get a graph. Also, do I need to worry about like negative amounts of tables? Am I going to have any negatives? What do you think, Madeline?
Oh, no.
No, we don't really have to worry about negatives. So when we draw our graph, pretty much the entire problem is going to be in the upper right. We don't even need this in the lower left. All right, you know what? I don't have enough room to go by twos. I'm gonna go by sixes. Okay, I'm gonna go by sixes. So let's label. That way we won't have to draw it as big. This will be 0,
You
6.
don't have the chart.
What's that?
You don't have the chart.
I know, you'll just have, yeah, you gotta draw your own chart for this one. So 6, 12, 18, 24, 30, and I'm gonna do the same thing this way. 0, 6, 12, 18, 24, and 30. So I'm going by sixes. Okay, what's my x-intercept? 30. So I'm going to put a dot over on 30. What's my y-intercept? 18. So I'm going to put a dot on 18. And what do I need to do now?
Draw one.
Yeah, just connect the dots, but don't go into the negatives because you can't have negative amounts of tables. Right, so we're just going to connect the two dots. So there's our graph. Any question on the graph? Right, now, what I'm going to do is I am going to graph this same thing, but I'm going to do it on the calculator so I can make it a little bigger so you guys can see it better. You don't have to know how to graph it on the calculator. What we graphed on paper, that was perfect. So let's do y equals negative -6 tenths x. Again, don't worry at all about what I'm typing in. -6 divided by 10 and plus 18. All right, and let's see if this looks like our graph. 0, 18, 30. And again, just because I didn't give you guys graph paper, that's all. All right, does that look kind of like ours? Let's see, if you're looking at, just look at that part that's in the box right there. Yeah. Okay. So let's take that and let's see if I can. Let's put on the grid line. Okay. So I think that might make it a little easier to see. Let's see. Okay. So there's our graph, just a little bit bigger so we can see it easier. That's exactly what you guys just drew. Now it says, find 4 possible solutions to the problem. Okay. A solution to this problem is any point that's on that line. Right. So what I'm going to do, I think to even make it a little easier, I'm going to draw the line thinner. And I think that'll make it easier to see. So we have to find 2 points that are exactly on the line. Well, we already have 2 points that we know are on the line. We've got one up here, and we have one over here. Can someone remind me, what was the point that was up at the top? Yeah, if you count, it was at 18. And what's the coordinate of that? Coordinate of my y-intercept?
18.
0, comma
18.
18. Okay. What was the coordinate of the x-intercept?
30 and 0.
Yep. 30, 0. Now I need to find 2 other points that look like they are exactly on that line. Does anyone think they see another point? It would be nice if it was like right where 2 grid lines lined up. Does anyone think they see one? Eli, you see one?
Yeah, right at the center.
Right at the center? Yeah, this one right here? Yep, that one looks like a good one. Because that's going to be easy for me to find because I can count in a second and figure it out. Does anybody see another one?
There's one that's like 1, 2, 3, 6 up, I think.
6 up? 1, 2, 3,
Maybe
4,
not
5,
six.
6.
Maybe not 6 up.
Yeah, that looks good right there, yeah.
And then there's one that's like 12 maybe.
Yeah, there's some other ones. I think there's like another one right up here.
And there's one, a few from the line.
And then down there, yeah. We only need 4 though. We need to find 4 points. Okay, let's label this one. This one is right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And how many up? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's that one. And then this one was up 1, 2, 3, 4, 5, 6. And how many over? Well, this was 15. So 16, 17, 18, 19, 20. Okay. So now let's write down these answers. What was x in this problem?
6. Wait, no.
What does it represent?
30? Oh no, X is the number of small tables.
X is the number of small tables you need, and what's y?
Big table.
Big tables. These points are telling me exactly how many tables I need to get to seat 180 people. It's exactly what they're telling me. All right, let's write them down. So let's put small tables, large tables. And we're going to write down 4 answers that are going to seat exactly 180 people. Can someone give me one arrangement of tables that will seat 180 people? Yeah?
26.
Yeah. You could get 20 small tables, and you could get 6 large tables. Okay, let's just check it. How many people fit at a small table?
6.
6. If I get 20 small tables and I can fit 6 people at a table, that'll seat 120 people. And how many people fit at a large table?
10.
10. So if I rent 6 large tables and I put 10 people at a table, I can fit 60 more people. And if I add up 120 people plus 60 people, how many people does that give me? 180. Yeah. So that's exactly what I want to fit. Okay. What would be another arrangement of tables I could do? Yeah.
30, 0.
Yeah. I could say, forget large tables. I'm just going to get all small tables, no large tables at all. Yeah. What's another arrangement?
15 and 9.
Yeah. I could do 15 small and 9 large. Or, what's my last arrangement?
0 and 18.
Yeah, I could say, you know what, I'm not going to get any small tables. I'm just going to rent 18 large tables. And there we go. So on the homework, I will make sure you have a grid like that so it's easier to see. I just did it because I forgot to copy the grid on your notes. All right, and that's it for today. Okay, so the homework is the worksheet on 3.4. Remember, progress reports close this week, and we will have on Friday, and we're going to have a review day on Thursday, and I'll be after school on Thursday as well.